PVS the Tutor. Welcome to another video. Now in today's video we are going to look at chemistry. It's talking about chlorine is a gas at room temperature. Iodine is a solid at room temperature. A sample of chlorine has a volume of 240 cubic centimeters at room temperature and pressure. The pressure of the sample is increased at room temperature. As you can see, describe and explain in terms of the kinetic particle theory what happens to the volume of the sample. Now they are saying that pressure is increased. What happens to the volume? When you increase pressure, what happens to the volume of a substance? Even when you relate it using the Boyle's law or the Charles law, sorry, I wrote for concentration. Where there are these two, we also have this one. This is Boyle's law, and this is Charles' law. And from here you can clearly see that pressure and volume are inversely related. That means if you increase from this, where you have pressure and volume, so eventually if you increase pressure, volume decreases. So here we are saying volume decreases. Now we need to explain this. The question is, why does this happen? The reason is simple. As we decrease the volume, what happens? The particles become closer together. Actually, when the volume of a container or the sample decreases, it shortens the spaces between the particles, which increases the pressure. So here we are saying that the particles move closer to one another, creating fewer spaces. B. When heated at atmospheric pressure, iodine changes directly into a gas without becoming a liquid. And we are saying iodine here is a solid, but when you heat it, it directly changes into a gas. This is a process that we know as sublimation. Describe the changes in particle separation, arrangement, and motion during this change. So, from solid to gas, how does the separation, arrangement, and motion of the particles change? Well, when talk of separation, they move apart. Here I'm saying particles move what in? Apart. What about arrangement? Of course, they move in an ordered, from ordered to random. Particles move randomly in a disorderly manner. In a disorderly manner. Motion, how do they are randomly. Not move, particles. Let me just say they are randomly. Yeah, that's how they are arranged. It's like there's a random arrangement, a disorderly arrangement. Now, when you talk of motion, all right, now in a solid, the particles will always vibrate about a fixed point or position. That means here, as you move to gas, it means the particles now will be moving from one place to another. So here, particles move from one place to another, where you can just call it a random motion. Here we're talking about a random arrangement, by the way. This. At the same temperature and pressure, the rate of diffusion of chlorine gas is greater than that of iodine. Explain why. At the same temperature, if we keep the same temperature, they are saying, and pressure, the rate of diffusion of chlorine gas is greater than that of iodine gas. What do we know about iodine and what do we know about chlorine? Okay, it all has to do with their masses on the periodic table. Okay, I think if I'm not, let me just confirm the mass number. So the mass of iodine is about 127 and the mass of chlorine is about 35.5. You can clearly see that chlorine is lighter than iodine, and this is the reason why chlorine can easily diffuse than iodine, because it has got a smaller mass. Okay, are we there? So we can say chlorine has a lower relative molecular mass, okay, than iodine. That's all. The symbol for iodine is given as this. Complete the table 7.1 about this iodine. So for me, I use 127 because I round it off. Usually it's 126.9 something. I just had to round it off. But use the one which is on the periodic table, by the way. Right. So they are saying the symbol for iodine is one iodine ion. Please take note. Ion is 126 and 53. 153 is atomic number and 126 is a mass number. Now this one is an ion, is charged. Complete the table below about this iodine ion. Iodine is defined in group what? 7. It means iodine is a nonmetal which can only accept one electron, because in group 7 it can only accept one electron. So already iodine has iodine ion, the way it is like this, it has got an extra ion added to it. So now you discover that electrons are actually more. So instead of having 53 electrons, it has got 54 electrons, but the neutron would remain the same. Even protons remain the same. The protons are not tempered when it comes to bonding. It's only the electrons. So since initially iodine has got 53, now that it's an ion, the electrons are going to increase. They're going to go to 54. But the proton number and the neutron number, they remain as they are from the word go, which is 126 minus 53, which will give you 3 here, 12, 73. This is why we are getting 73 here. So it will just remain the same. For the neutrons and protons, it's only the electrons that will be tempered with. This applies to all other metals or non-metals involved in bonding. Those that can lose, they will decrease the number of electrons. Those that can accept, they will increase the number of electrons. So clearly, I hope this video helps. Follow for more.